Hello everyone, welcome to lesson 6-1. Solve one-step addition and subtraction equations. In this chapter we're going to be asking the essential question, what does it mean to say two quantities are equal? And for vocabulary we're going to look at equation, solution, equivalent equation, subtraction property of equality, and addition property of equality. Okay, let's see. Let's use the vocabulary in real-world context. I will explain as I read along. An equation is a sentence stating that two quantities are equal. When they say the word sentence, they're talking about a number sentence. Okay? Like you see here. That's a number sentence. X plus 2 equals 6. And equal means they are the same. So 6 and x plus 2 are the same. The value of a variable that makes an equation true is called the solution of the equation. So the value of the variable. What is the variable? So here we have the variable x. What is that value? Well, when we find the value of this, that's our solution of the equation. And that's what we're looking for. Now, a number plus 2 is 6. A lot of you probably already figured out that this x is 4, because 4 plus 2 is 6, correct? The only number that can make this statement, this sentence, true. So let's look here. We have a value plus 2. If we take away 2 from this side, we're just left with x. And to make the sentence true, we also have to take the 2 away from this side. That is called subtraction property of equality. Whatever you subtract from one side, you must subtract from the other side. So if we take the 2 away so that we can isolate the x or leave the x all by itself, and on this side we take 2 away, we're left with 4. So our solution is x equals 4. With the picture, we can use, for example, x plus 2, and you see over here we have equals 6. 2, 4, 6. If we take those 2 away and we're left with just the x, we must take 2 away from this side as well, and we're left with 4. So x must be 4. Okay, I hope that made sense to you. If it didn't, feel free to watch it again. The equation is x plus 2 equals 6, and x equals 4 are equivalent equations. So because they have the same solution, 4. Okay, both sides are 4. X is 4. Circle the equations below that are equivalent to x equals 3. So x is 3. Use algebraic tiles if needed. These are called algebraic tiles or algebra tiles. Okay, a number plus 3 is 6. If I make x 3, doesn't make it true. 3 plus 3 is 6. So yes, we can definitely circle this one. Alright, next one. Again, x is 3. So I'm just saying 3 plus 1 is 6. No, 3 plus 1 is 4. So I'm not circling that one. 3 plus 6 is 8. No, 3 plus 6 is 9. 3 plus 3 is 3. No. 3 plus 1 is 4. That one is true. Remember, x is 3. We're making those equal. And then x plus 2, or 3 plus 2 equals 5. Okay, there we go. Right? Let's keep going down. Real world connection. So how do we use algebra in real world? Video games. Robin had some video games, and then she bought 4 more games. So she had some video games. We don't know what this some video games is. So that's going to be represented by x, some video games. And then she bought 4 more games. So she's adding 4 to a value that we don't know. So it's x plus 4. Now she has 10 in total. See that? Now she has 10 in total. So that's 10. So some games she had before, then she bought 4, now she has 10. So that's how it goes. Using the equation, so this scenario can be described using the equation x plus 4 equals 10. You know already what x is. X must be 6, because 6 plus 4 is 10. A lot of you can figure that out just by using number sense. What does x represent in this equation? Well, the x represents the number of games Robin started with. So the number of games she started with, some video games. That's what x is. Write two different equations that are equivalent to x plus 4 equals 10. Well, one would be, we already know, x equals 6. That would make it true. Or, if we wanted to, 2 times x, so 2x, equals 12. Since we already know that x is 6, right? Because over here, if we were to use subtraction property of equality to subtract the 4 from both sides, it would look like this. I'm going to subtract 4, and I'm going to subtract 4. Now that I've done that, these 4 are gone, so I'm left with x all isolated equals 10 minus 4 equals 6. See? So x is 6. And that makes these statements true. X is 6, and 2 times x is 12. And here we have our key concept for today's lesson. Subtraction property of equality. That's what we were just using when I subtracted the 4. The subtraction property of equality states that the two sides of an equation remain equal when you subtract the same number from each side. So symbols. If A is B, then A minus C equals B minus C. So whatever I take away from one side, I must take away from the other side so that this remains true. Right? Okay, so you can use bar diagrams and the work backward problem solving strategy to solve equations arithmetically. Or you can use the properties of equality to solve equations algebraically. So we're going to use properties of equality. As you can see here, we've already explained, you have a number plus 6 is 4. Oh, but wait, I'm adding plus 6 to a number, so this number must be in the negatives. If it's going to, when I add 6 to it, it's only going to give me 4. This number must be below 0, correct? Well, using property of equality, I'm going to take away that 6 by using subtraction property of equality, and I have to do the same to the 4. Whatever you do to one side of the equation, you must do to the other. And yep, I'm left with just x on this side of the equation equals negative 2. And then when you can check by putting the negative 2 into the equation, substituting, and you'll see that 4 is 4. So the solution is negative 2. B. Now we've kind of flipped it and we're saying negative 5 is the same as, it's equals to b plus 8. What can be b? So that if when I add 8 to it, it brings me to negative 5. It must be a really low number, like negative 13. If I have negative 13 and I add 8 to it, it's going to bring me up to negative 5, closer to 0, right? So let's just try. I want to isolate b, so I'm going to get rid of this plus 8 with subtraction, negative 8. I must do the same to the other side. Negative 8, or subtract 8, I get negative 13. So, and here I'm just left with b, right? Because this side cancels itself out. And we can check. Okay, if you think you got it, I want you to use subtraction property of equality to subtract all of these values so that you can isolate your variable. So you must subtract 6 here and 6 on this side. You must subtract 3 here and 3 on this side. And you must subtract 4 here and 4 on this side. Remember, always subtract the number that's being added to the variable. Okay, pause the video and try it now. Okay, let's try A. I hope you've done it already and you are just watching to check your answer. We have to use subtraction property of equality. I'm going to subtract 6 so that I can isolate my variable, leave it all by itself. And whatever I do to one side of the equation, I must do to the other side. So subtract 6 on this side. These 6's cancel each other out, they're gone. So I'm left with just y equals 9 minus 6, 3. So y is 3. Is that true? Well, if I put a 3 here, and I say 3 plus 6, yeah, it equals 9. So it is true. The solution is 3. B. Again, we must use subtraction property of equality so we can isolate our variable. So the 3's are gone, and I'm just left with that x right there, right? This x equals, I must subtract 3 from this side as well, and 1 minus 3 equals negative 2. And that makes sense, right? Negative 2 plus 3 is positive 1. And finally, C. I'm going to solve for A. So I want to isolate this A right here. So I have to take away this 4. And I have to use subtraction property of equality. So minus 4. Whatever I do to one side, I must do to the other side. Minus 4. And now I have A is negative 7, right? Because negative 3, negative 4, all together I have negative 7. Okay, now I think we're ready for a word problem. An angelfish can grow to be 12 inches long, so exactly a foot. If an angelfish is 8.5 inches longer than a clownfish, how long is the clownfish? Okay, so we're saying, now let's read this carefully. We're saying that an angelfish can grow to be 12 inches. So the total is 12 inches. And that 12 inches, let's keep reading. If an angelfish is 8.5 inches longer than a clownfish, that means we have a clownfish plus 8.5 inches. That makes our angelfish, because we just said an angelfish is 8.5 bigger than a clownfish. So an angelfish is this, the clownfish plus 8.5, right? That's what it is right there. That's what an angelfish is. So we can solve for a clownfish. So let's look here. In words, an angelfish is 8.5 inches longer than a clownfish. Yep, you got your clownfish, 8.5 longer will give you your angelfish. Variable, let C represent the length of the clownfish, because that's the variable, we don't know what it is. So equation, you have 12 equals the clownfish plus 8.5. Right, I just wrote it this way, but it's the same thing. Okay, so let's see. We have to use subtraction property of equality to get rid of the 8.5 because we want to find C and leave it all by itself. Whatever you do to one side, you must do to the other side. You subtract 8.5, subtract 8.5, and you get 3.5 C. So a clownfish is 3.5 inches long. Let's try the same for D. We'll read it together, and then I want you to pause and try it on your own. The highest recorded temperature in Warsaw, Missouri is 118 Fahrenheit. This is 158 greater than the city's lowest recorded temperature. So it's a big range. Hottest day, and the hottest day is that much hotter than their coldest day. Find the lowest recorded temperature. Okay, I'm going to pause the video now, or I want you to pause the video now, and play it again when you've found your answer, or at least when you tried to find your answer. Okay, I hope you've tried to find your answer, and I really hope you found your answer. So we're saying that 118 right there is our record hot, and that 118 is made up of 158 and something else plus what is that we're looking for? Find the lowest recorded temperature. There we go. The lowest recorded temperature will be represented by T. So if we start off with 118 consists of a range of 158 plus the temperature. That means this number needs to be negative, right? So that we can get what the temperature is. So again, let's just use subtraction property of equality. We're going to subtract 158 from both sides. Subtract 158, right? This is gone, becomes 0, but I don't have to put in my equation. I just bring down the t, because that's all I have left. And t equals 118, take away 158. I'm taking more away. Well, the difference between those two is 40. And it's a negative 40, right? Because I'm taking more away than what I have. So the temperature is negative 40 Fahrenheit. And then you would put that unit into your therefore statement, not in the equation like I've just done. That's not the proper format. You want to say therefore and write your statement out. I can't write with this big pen. But you would say something along the lines, The lowest recorded temperature in Missouri is negative 40 Fahrenheit. So now we're going to look at the second key point for this lesson. We already looked at subtraction property of equality, where we take away a number. Now we're going to look at addition property of equality, where we add a number. So the addition property of equality states that the two sides of the equation remain equal when you add the same number to each side. So if A is B, then if we add C to A, we must add C to B to keep it true. So let's see. So when you add because you're taking away, and that's the only way we can bring that number to 0. So we have x minus 2 is 1. We want to get rid of that minus 2, so we must add 2 to bring it to 0, so that we're just left with x. And whatever you do to one side of the equation, you must do to the other side. So x equals 3. Is that true? 3 minus 2 is 1. Correct. Okay. Here is questions E to G. Go ahead, pause the video, and try it on your own. Okay, I hope you paused the video. We've got first question is y minus 3 equals 4. I'm going to use addition property of equality to get rid of the 3. When you do to one side, you must do to the other side. That's gone, so I'm just left with y. Y equals 7. Okay, let's try now f. Okay, I've got r minus 4 equals negative 2. Get rid of the minus 4 so by adding 4. Addition property of equality on both sides. Addition property of equality. That's gone. So I've got r equals 2. Negative 2 plus 4 is 2. And then finally, let's try G, where I have Q minus 8 equals negative 9. I must use addition property of equality to get rid of the 8, so I must add 8, and that brings that to 0. So I'm just left with Q equals, I have plus 8 on this side, and I get negative 1. Negative 9 plus 8 is negative 1. Okay, I hope that makes sense to you. And finally, using property of equality, addition property of equality in a word problem. A pair of shoes costs $25. This is $14 less than the cost of a pair of jeans. Find the cost of the jeans. So this is 25 less. So 25 is the jeans minus 14, right? You can see here, 25 is the cost of the shoes. This is 14 less. This is 14 less than the jeans. So let's add it up at 14, and you just have to go up and you get your 39. So the jeans were $39. Let's try H. Let's read it together first, and then you will pause the video and try it on your own. The average lifespan of a tiger is 17 years. This is 3 years less than the average lifespan of a lion. Write and solve an equation to find the average lifespan of a lion. Okay, go ahead, pause your video now, and we can check your work. Okay, I hope you paused your video. So let's see here. We've got the average lifespan of a tiger is 17. So that's the lifespan. And what is 17 made out of? This is 3 years less. So that's 3 years less than what? Than the average lifespan of a lion. So I'm going to write it like that. So the tiger is 17, and that is 3 less than the lion. If you really wanted to, you could write it backwards as well, or the other way around. You could write the lion minus 3 is the tiger, right? The lion's age minus 3 is the tiger. Whichever way you write it, you have to use addition property of equality. So we're going to add 3 to this side and add 3 to the other side of the equation. The 3's are gone because negative 3 plus 3 is 0. And we're just left with the lion's age. And the lion's age is 20. Therefore, you would want to answer with a therefore statement. I'll write it down this time. Therefore, the lifespan of a lion is 20 years. And here's your guided practice. Remember, when you complete the guided practice and the independent practice, you can always go back to the videos, to these examples. So when you're doing 1, 2, 3, and if you can't remember to do it, go back to the examples in the videos where you have examples 1, 2, 3, and you can see how it's done. And for question 4, you have examples 5, 3, and 5. Okay, see you next class.